Here we are again. Welcome to Headwater Science Center in our after 3:30 show again. Are you want to be in the show?
Sure.
I'm prodding my audience and volunteers to see if they want to help me out with this thing. So we've been doing these shows here now for how long, Ryan? 6-8 months now?
Yeah,
Longer than we thought we would be. We're still doing them.
September, pretty much.
We just don't know how to. We don't have an off switch. We turn us on. We just stay going at what we've been doing. And we've done liquid nitrogen several times, but we just got a fresh can. We filled this one up just last week, and last Saturday we had a snake demonstration. So we're going to do this, what I had planned to do last week, today. And those of you who are not familiar with liquid nitrogen, nitrogen itself is a curious substance. It's what we breathe, or at least part of what we breathe every day. 4/5, 80%, 79%, something like that, of the atmosphere that's here down at the surface of the earth near sea level. And, you know, we're only 1,000 or 1,300 feet up, so we're near sea level, is nitrogen. The other things we need there, well, really just oxygen, a little moisture to keep us comfortable. So, but we get this nitrogen right from this air, right from this gas. And so, to make liquid nitrogen, what do you think you do? What do you do? I'm asking my audience here. What would you do? They don't know. A lot of people don't know because it's not well known. But I'm going to tell you what happens is you've got so much nitrogen in this air. There's a reason. There's no good reason not to use it. So if you squeeze it together, it gets hot, and we need it to get cold. But if you squeeze it together, take the heat off, squeeze some more, take the heat off, eventually it will become liquid, and it'll reach a temperature down minus 321 degrees when it becomes liquid. It's got a short liquid phase. I'm going to pour some of this out. You can see it looks like water. Looks like water. Doesn't quite pour like water. It kind of hangs together. It actually hangs together in two nitrogen atoms that are connected, so it's N2 really. I'm going to pour some of that in there. And one of the reasons we're doing this, because we have it, is because even if we just keep it right there in the can, we lose anywhere from 2 to 5% a day. So if you don't use it, you definitely lose it. Now, let's ask our team here. Have you ever handled liquid nitrogen?
No.
Should you handle liquid nitrogen?
No.
They say no. Well, I say let's try it out and see what should happen. Now, I know we've done this. We just did it last week. But I'm going to try to come up with some things that maybe weren't done last week. Let's just do a couple of things right away. One of the things I want to do is, in here I have plain water. I'm going to pour some of that into here. Oh, making a mess. You can see that water is falling itself down into there. My funnel is not very fast. And my goggles, camera shot, are fogging up terribly. These things don't help us out with that much, so I do protect my eyes, and I consider that an important part of this because that's where it can be the most problematic for me. If it touches my skin, it bounces right off. That's okay. It touches my skin, but my eyeballs are made of liquid essentially, and they don't do well with that contact. So let's just pour some in there. Oh, that might spit back at us a little bit here. We'll even go down because of the pressure. We can let that in. There it goes. Thought we'd get a spit point. So, what are we seeing here? We're seeing it burst out the top under pressure. Now, what's that pressure? What is that liquid that's now gas doing after it reaches the top? Pull these off now because the spit point is over. It actually is a lovely cloud, isn't it? It's beautiful, isn't it? Tell them and convince them. But then it falls. Why does it fall? Why does it rise then fall?
Because of heat?
Well, because of lack of heat, because it's colder than the air, and so that is mostly water vapor and some other things that got mixed in with that reaction, and it rises out of there, and then it falls. Well, that happens in a lot of different vessels. Let's try it in this one. I thought maybe that I didn't have the effect I wanted in there. I wanted more, ooh, ah, wow. Didn't get them. Didn't get it at all. So if you want to add a ooh, ah, Wow! Go ahead, add it. But only if you're feeling it, because I don't want any false ones. Don't give it to me till I earn it. Oh, I don't know if I earned that or not. I want to pour that back over there. I have too much. All right, let's put some. Oh, I still have some here conveniently. Let's pour that right in. Ooh. I thought it was prettier coming out of there, didn't you? But it looks pretty lofty and heavy, and we're getting a cloud on the ground, and it's a nice effect. And what I wanted to think, here's what I thought. Let me see. I wanted to try something. I thought might dance for us. It doesn't. I had another ball I thought might dance, but let's see. So what is this gas? We didn't put this much liquid in, did we? And yet we're getting a whole lot of gas, a whole lot more gas still. And gas takes up a lot more room than liquid, depending on what you have. 500, 600, even 800 times more space for the same substance in a gas form than in a liquid form. So that one out there. And this is still giving off its lovely funnel of nitrogen. All right, let me try something else here for you. My funnel was a bit of a letdown. I want to get rid of some of that excess water. I got too much. Okay, so here was something I just used to do. Let's see if we can pull this one off again. I'm going to grab some nitrogen. I want you to see it because I don't want you to think I have this thing I'm doing in the magic bucket. So this is just ordinary chalk. Put that in there. Put that in there. Oh, I wanted to try a big one. Doesn't fit. It's a show, right? All right, put it in there. We'll put it in there. Anybody have any predictions, or why the heck would you even do that? Questions. We got that question? Ask the question. Why the heck would you even do that?
So you said it was chalk you put in there?
It was chalk. It was schoolroom chalk. Why the heck would you even do that? Just ask it.
So why would you do that?
Why the heck would you do that? Well, let's see. I don't know. This is one I did not rehearse, so maybe there's no reason I should have done that. So maybe it was just a silly thing to do. But if you know chalk has pores in it, and let's see what happens when it starts to warm up. Put it over here. It's interesting, but it isn't doing what I thought it might do. I thought what it might do is capture some of that nitrogen into the pores of the chalk, and then it might kind of dance a little bit for us. I don't see any dancing going on there. But they certainly do have some nitrogen in there. And it's letting some of that go. Yeah.
You can see.
Are we getting a little dance?
So you can see it pouring out of that yellow one really well.
You can see it pouring out of there, yeah. Well, we're showing that. But I thought we could get a little dance off that. We're not done trying to dance. Let's try something else. If at first you don't succeed, try a different experiment. So here's what I'm going to show you. This is a trick I used to do, but I haven't done this for a while. Is I put 2 holes in a should go that way. Got one going that way, so that would go that way. This would go this way. This way. See, that way. That way. So I've got a couple of holes in that ping pong ball. Now it's not a very good ping pong ball anymore, but it could be fun for this. Let's try that. I'm gonna have to sink that down in there. I hear it. There's definitely some cooling going on. Let's verify that we actually have an effect happening. So that temperature of the ball is giving up all of its heat, at least to minus 321 degrees Fahrenheit. And it's also filling up a little bit with liquid nitrogen. It's still boiling away, so I'm going to keep it on. Make sure we get full. When it stops boiling, it's pretty much down to temperature. And we're getting close. All right, this one can be messy. Let's see how that goes. gotta make something work for us good today. Oh, here we go. Oh, they broke the tray. Oh, chaos, water in the scene. Where'd my ball go? Well, it's shaking. Put it back in. We have the messiest table I've ever had. I'm gonna hold that down in there with this. I think I just needed a, oh, it wasn't cold, but we just got through another Minnesota winter, so we're gonna consider that not cold enough to bother us.
So you said your plate cracked there?
My plate did crack. It got a little bit of nitrogen out of it, cracked right away. That's that cheapy old plastic. Let's see if we can get this to go. This is the spitter, so. Oh, I feel it spitting at me. Oh.
So you've got liquid
I've got
nitrogen.
liquid nitrogen in there and 2 little holes that are directed as jets to make it. There's one. I got to get them jetted in the right direction. Remember, that's the direction. Doesn't take as long to get it down the second time. There we go. Well, this is why I stopped doing this one, because it was unreliable. We're not giving up on it, we're just not succeeding at it either. Let's try something else. So what's in this balloon?
Helium.
Audience, good guess, helium. We know it's lighter than air. Let's put it in here just to see, just because. How about this balloon? What's in there? You don't really know, do you? Not lighter than air. It's actually heavier than air. But let's say I wanted to get this balloon in here. What would you do?
Deflate it?
Good, but then I wouldn't have the air anymore. Let's say this had the last breath of fresh air before I became cynical and I wanted to save it. What would I do?
Why don't you put it in the
Put it into liquid nitrogen? Okay. I'll do that in just a second. That helium balloon wants to come back out. First I'm going to do that. And then gases grow, they take up so much more space. But that also means that when we cool them down, they take up a profoundly less amount of space. Put that in there. I'll put that helium balloon back in here. And they also reinvigorate themselves in size pretty quickly. As soon as that warms up in there a little bit. Meanwhile, this helium balloon that used to floats why? Why do helium balloons even float? Because we have birthday parties and we need to have fun. Helium is lighter than the same amount of air that it displaces, just like things float in the water. That's a similar reason why they float up in the gas of the air. So helium balloons float. So now they do. What changed? The gas was locked in there. It was never more or less than there ever was. It was just the shape it was and then how close the molecules were together. What happened?
Was it compressed?
It was compressed, but why didn't it float when it was compressed? It was the same weight. The weight didn't change. It's locked in the balloon. Try it again. The gas and the weight don't change. They're locked in the balloon. But now that gas forms out quickly, especially helium. And now it rises. Because when it has to get lighter than the same amount of volume of air that it displaces for it to rise up through it. It's the same thing in liquid floating and the likes thereof.
So when it came out of the nitrogen, it was a smaller balloon. It was occupying
It was a
less
much
space.
smaller balloon, and so it did not have that characteristic of being lighter than the same amount of gas, air gas that we breathe in.
Same weight, lesser volume.
Less volume. It was the volume that changed, right? So the weight, in fact, it might have been a little heavier because we had a little bit of nitro in it. Come on. Well, that one will have to keep working. I think I'm going to have to make a special ball that I like. Let's try something else. Now, I always like to start a good story with another good story. Now, let's say that I just got this banana from the co-op. Is that a real banana?
Yeah. Yeah.
Does anybody want to prove that's a real banana? Think about it. No trick bananas here at the show. That was the least confident bite I've ever seen anyone take. You think I was tricking you or punking you? All right, we're gonna try it.
I mean, there's always a chance.
All right, let me cut that out. But that is a real banana, right?
Yeah.
That's all I really needed. Just remind me that you take bites like that. I'm gonna see if I can make a hammer out of this banana. I'm sure you've seen or heard about this. With that noise. All right, meanwhile, let's try something else. How are we gonna get this out of here? New ideas are welcomed, warranted, wanted. Anybody in the audience out there in electro land want to give us a ponderance and a wonder about? What do you think? I'm wearing my glasses.
The solution's been liquid nitrogen most of the time today.
It's been most of the time. I like it when the same right answer keeps coming back through, so let's keep doing it. At first it's going to shrink. Then it comes right on out of there. It had to. It had no choice. It had to come out of there. Well, let's say... I still have a banana here that's kind of...
Yeah, why do you think that happened?
Huh?
I know. It just.
What did you
popped
know?
out.
I didn't even want this Chuck. I want this Chuck.
That's amazing.
Get back over there. My glasses are doing good now. Wherever I'm wearing them now, they're working. You can see what changed on me. I'm not. Oh, I froze to the jar, to the tray there. This over here. Something's going on over there. There it is. Chop. There, we're making a mess now. So we do have pressure coming out of there. Let's put some more water in there, make that happen faster. Well, why do you think it happens faster with who's got some nitro in there? Let's put some more of this in here. You've seen that effect already. So yeah, that pressure coming out of there, hot pot on the stove. What is boiling? I think this is one that gets us thrown around. I think in our brain somewhere we have the idea that boiling equals hot, and I just told you this is 321 degrees below zero, and it's boiling. Why? Why does it boil at that low temperature? Is there something wrong with our definition of boiling? Maybe there is.
Related, but when we were taking the chalk out, one of the suggested reasons why we were putting it in there was to freeze the chalk too, which is the same issue, but
the chalk was already solid. It had pores in it. We were trying to get it to lock and dance a little bit like, sort of like this effect. But what is that? Water? Okay. Let's try putting some more liquid nitrogen in this one. Don't it back at me. And see what happens to this. Wait a minute. What is this? Can you hear that?
Yeah.
Why? You always can get surprised. Why does it make the sound on here?
Yeah.
Sometimes we have to go back and look at the tape and try and figure out why things happen. When we were in the echo tube the other day, Ryan, remember we got that crazy sound? We were getting like a feedback sound out of there. I figured that one out in my sleep sometimes. Let's say I wanted to put some of this in here and then, whoa! That won't hold the top on, will it? Wasn't I going to give you this for your birthday?
What?
Wasn't it your birthday day?
It was my birthday in March, like the beginning of March.
Well, see, I missed it. So I was going to give you some of this stuff. I promised you that. And I thought I'd put it in a jug like this. I've been waiting pretty long on that. Trying to do too many things. So I'm going to put the cap on. Oh, here. Find the cap for that. Put the cap back on that. And I'm going to redo my hammer. Yeah, you need to get a cap on this stuff or it'll spill, right? So put it on extra hard. That'll stay this time. It's going to pop? Oh, yes, it is. It won't stay. It won't stay because it's, again, as we said, when it turns to a gas, it takes up about 600 or 800 times more volume than it used to. So it has to And that's to expand. It'll break right through those containers. And those containers, while they are pretty rugged, they're not that rugged. Warm that up. Okay. Put that in there. We're making a new hammer, can you tell? We waited too long on the last one.
So what happened when you left it in there too long?
I have the example of it right here somewhere. It split open. It expanded and split wide open on me. Oh, there it is. There's my example. I'll get the example off. Because if you can't learn from your mistakes, you can't do science. Because
so everything else we've talked about today, when it got cold, it got smaller, but the banana expanded.
But the water inside this banana expands when it freezes. That's the kooky thing about water. It grows by 8% when it forms into its ice structures. It's crystalline glass. I know, and that one throws a person around a little bit because we often think that water is the standard when in fact water is not. Water is actually kind of weird stuff. I'm gonna need that again, and it'll act strangely for you. All right, let's look at this one. We got the space here. Got the messiest table here I've had all week. Get that out of here. We broke it already. So, can you use a banana as a hammer? The answer is, yeah, if you do it right. That'll work. It's good and hard. That works. Let's put this in there. You should always have something in the liquid nitrogen when you have it bubbling away on you. Let's try this. Oh, I wanted to show you this. We're sort of getting into this. I have to use my borrowed air from the room. One just see was genuine. Okay. I'll get that mask back on for you, so you folks at home stay safe. Put that mask back on, and then my lung gas. What happens when I put that inside the liquid nitrogen?
Well,
it's gonna shrink.
Yeah.
And maybe something that you don't expect happens. So stay tuned for that. I'm gonna need to show this one close on the camera. This has always been one of my favorite ideas. So the gas I've been surviving on in this air has been chilled down to minus 321 degrees, and we're actually creating. See that milky substance in there? That milky. That's my old breath, or at least that's the breath I was breathing. I did get a little bit of less sustaining life off it, but now as it heats up, it starts to become gas again, and expanding, and now that little puddle of milk is gone. I wonder why it comes out milky though. I mean, shouldn't it be clear? No, it comes out milky. It must be the mix of nitrogen and carbon dioxide and oxygen. So there was some liquid oxygen in there as well, and that would have made that slightly flammable if we could have pulled that off of there. All right, we've got that. We've done that. We've shown that. Let's freeze this ball for us. What kind of ball?
Bouncy ball.
Bouncy ball. Put that in there. I'm gonna throw another piece of chalk in there, see if that does anything. Sometimes things will surprise you and work when you're not expecting them to. Maybe it's the bigger pieces that are cooler. Let's try it. All right. Again, looks like it used to look, right? Get that out of here. All right, let's put some water in here. See what we got going on in the liquid nitrogen. What's going on in there? Oh, the chocolate's doing something. It's doing something in here. How'd that get in there? Oh, I know how I put that in there. I thought it was something else. All right, let's take that ball back out, that formal bouncy ball. Doesn't even act like it used to act because now the pores are tightened up and those are refusing to dance. I've never done that before. It doesn't work. At least not very well the way I do it. How about, we talked about shrinking. Will this metal shrink?
No.
No? Okay. Try that to see. See if that works out. I've shown you that. I've shown you that. I've shown you. Didn't this shrink for us? You know what my favorite thing so far was? It was the weirdest little silly thing. It was this. I think it needs a little more liquid. I thought that was fun. And I didn't like it going in with a funnel. I just liked the way it looked. Now it's going to start spitting it back at me. I think that looks like a nice cocktail, doesn't it?
It'd be an interesting cocktail to see it.
Yeah, yeah. We could drink it for a while, and then it wouldn't would crack our teeth.
No.
It just looks cool coming out of that boiling flask. That's a boiling flask. That's why it's got the small hand down there. All right. Well, you wanted to know if this would shrink or not. So that ball used to fit through that ring, right? And now it does not.
Oh.
It shrunk. All right. Here comes the Minnesota kids. Can you tell me the truth? Yes. What would happen if I lick this?
It would stick.
It sticks to my tongue.
Yeah.
Who's done that experiment? The old flagpole with the tongue trick. Okay, so because this is minus 321 degrees below zero, and we Minnesotans know that sticks to our tongues. When you do this in California, they go, oh, I don't know, dude, it looks like an ice cream cone, lick it. They don't know, we do. So, should I lick it?
No,
No!
don't lick that.
My tongue's gonna freeze on there instantly. I'm not gonna do that, but I wanted you to know that we've done that experiment, and it was one of our first experiments, and it's a bad one. We should use somebody else's tongue on that deal, or a rag would have been the same thing, but whatever. We went through it. Okay, what else do I gotta show you? Oh,
So you threw the strip in there.
what's dripping? Do I have a leak in something?
Oh, that was the water that spilled.
Hmm. That's made of wood, so I should be able to hold that kind of.
Oops.
Well, no.
That was cool. All right, well, that did change too. Let's try this. These glasses are working so well, I can't believe they're on. Okay, they're on. Where's that? Yeah, I got a couple things I want to show you. I want to show you this. I have a piece of carpet down here. Why does it make that sound, do you think? It's warming up and it's got a lot of surface area, right? Yeah, that's what you said. All right, let's use up our nitrogen. Put some in there. Huh?
The sound when it hit the carpet kind of reminded me of fireworks far away.
Okay. You've been indoctrinated. You're officially indoctrinated in fog. Doesn't it smell like a lovely winter morning? No.
Smell it.
Well, that's because you had your. Oh, that means your mask is working. So you guys passed the mask is working test. Let me try something else for. I know we made a complete and total mess of things. How about this thing? Come back.
Yeah, coming back.
That is very hard.
That ball's been chilled down probably 1,000 times by now, at least 100.
Inside.
Put some of this in there. Anybody predicting what's going to happen when I do this and pour liquid nitrogen into it? More? Yeah?
Yeah, might as well.
More?
Yeah.
Yeah. More?
I think that's good.
That's it?
Yeah.
Okay. Okay.
What are we gonna use that much dish soap for?
Well,
If we're gonna use that much, just empty the bottle, in my opinion.
whatever. Let's just pour this in there and see what happens.
Whoa.
That's what we're going to use it for, Ryan.
I wanna eat that.
So these nitrogen bubbles here are showing us what we're going to use the dish soap for. That's all we have for our semi-filled, semi-successful show today. But we tried to do a couple things we don't do all the time. Tried to have a little nitrogen fun, but we certainly made a mess, didn't we? So you guys are going to clean up the mess?
They're here for.
I think you made it.
I got it. I got to put it all back. Well, so we're having another show. Not tomorrow. We're not here tomorrow.
We'll probably do a watch party tomorrow where we'll have some video and one of the staff people will be there, kind of in the comments to talk about what's going on in the video. Probably be Angie.
Okay, so Angie might be doing a walkthrough on some of our other footage. But we'll be back on Monday. Is that right, Brian? We're still on?
Yep. Should
We're
be
going to do
Monday.
this until we run out of
until we stop
electricity, until we stop doing it, until we can't want to do it anymore. We still like doing it. We hope you like it.